Welcome back to another section of laws of indices. In this video, we want to continue with the remaining laws of indices. Having exhausted 4 in our previous lesson, we want to look at the remaining part in this video. So the first one, which is rule number 5 that we'll be looking at in this video, is raising a power to another power. For instance, if you have a raised to power 3 multiplied by 2. The expansion of this means a raised to power 3 times a raised to power 3. And going by the previous law that says whenever we have the same base having different powers, we can take one of the bases and then add the powers together, and that will give us a raised to power 6. But instead of going through this, the laws of indices, which is rule number 5, says whenever we have a raised to power m that is being multiplied by n, we can say that a is raised to power m times n, which is a raised to power mn. For example, if you have 5 raised to power 3 being raised to another power of 3, all we have to do is to say 5 raised to power 3 times 3, which is 5 raised to power 9. And when we have 2 raised to power 4 raised to power 5, the expansion of this is going to give us 2 raised to power 4 times 5, which is 2 raised to power 20. Rule number 6 has to do with square roots. When you're given, for instance, 25 raised to power half, that is multiplying another 25 raised to power half. Going by the first rule, we say 25 is the base of each of them. Then we add their powers together plus 1 over 2. This is going to give us 25 raised to power 1, because half plus half will give us 1. And that is the same thing as 25. But if we have square root of 25 times square root of 25, we can see that we have 25, that is 25 raised to power 2 with 1 square, and we know clearly that whenever a square and a square root are meeting, then the two of them cancel out each other, and that is leaving us with ordinary 25. So if you look at this and what we have done here, we can come to conclusion that whenever we have a raised to power half, anytime you are given any number that is having a power of half, that is the same thing as square root of a. And also, we can also say safely that anytime we have square root of a, it can also be rewritten as a raised to power 1 over 2. If you are given 9 raised to power half, it is the same thing as square root of 9, which is equal to 3. The seventh rule has to do with cube roots and higher roots. If you have a raised to power 1 over 3 multiplied by another a raised to power 1 over 3 times another raised to power 1 over 3, we can rewrite them using the first law that says whenever the base are the same, we can add their powers. 1 over 3 plus 1 over 3 plus 1 over 3. And that is going to give us 1. So a raised to power 1 is the same thing as a. What if we now say the cube root of a times the cube root of a times the cube root of another a? Meaning we have 3 cube roots of a. When you collect a that is common to the 3 of them, the cube root that is common rather, then we have a in 3 places, which is a raised to power 3. And whenever a cube root is meeting a cube, they can cancel out each other, leaving us with only the alphabet. So we can say now that whenever we are given a raised to power 1 over m, the m being a cube or a fourth root or a fifth root, we can say that it is the m roots of that number. For example, if you have a raised to power 1 over 5, this is not cube in this place. This is going to give us the fifth root of a. And if we have a raised to power 1 over 4, this is going to give us the fourth root of a. And if we have 27 raised to power 1 over 3, this is going to give us the cube root of 27, and that is equal to 3, which means the number that will multiply by itself in 3 places to give us 27, and that is 3 by 3 by 3, which is equals to 3. Rule number 8 is dealing with when the numerator of fractional index is not 1. If you are given a number that have an index 2 raised to power 3, for instance, we can rewrite this as a raised to power 2, this 2 in the numerator, multiplied by 1 over 3. Don't forget that 1 over 3 from rule number 7 is the same thing as cube root of this a, leaving us with the square standing on its own. So we can rewrite this one as the cube root of a raised to power 2. Also, if we have m raised to power 5 over 4, this can be rewritten as m raised to power 5 times 1 over 4, and this 1 over 4 is the same thing as the fourth root of m, which is going to imply that we have 4 roots of m raised to power 5. So we can say in general that a raised to power m over n is the same thing as the nth root of a raised to power m. So if we are given, for instance, for an example, 27 raised to power 2 over 3, we can rewrite this as the cube root of 27 raised to power 2. And the cube root of 27 is 3. We still have a power of 2. 3 raised to power 2 is equal to 9. Also, if we are given 81 raised to power 2 over 4, let's say 3 over 4, then this is going to give us the fourth root of 81 raised to power 3. And the fourth root of 81 is also 3. That is 3 multiplying itself in 4 different places. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. So this is 3 raised to power 3, and that is going to give us 27. The last law of indices has to do with number raised to a negative index, which gives a reciprocal of the quantity. For example, if we have 9a squared over 25, which is also raised to 1 over 2 negative, what this is telling us that we are going to remove this negative by taking the denominator to the numerator and replacing the numerator as the denominator. So it is going to give us 25 over 9a squared raised to power 1 over 2. Ordinarily, on a good day, if we want to solve this one, we are going to be having 1 over 9a squared over 25 raised to power 1 over 2 due to this negative part. But when you express this, when you break it down, it is going to become 1 divided by 9a squared over 25 having a negative positive power of 1 over 2. And don't forget that whenever we have division, if we are changing the division to multiplication, then the numerator and the denominator has to change position. So we are going to be having 1 times 25 over 9a squared raised to power 1 over 2. So instead of going through this long process, then the law of indices says whenever you are having negative in the power side of any number, then remove the negative by replacing the numerator and the denominator in their each and different positions, saying 9a squared becoming the denominator and 25 becoming the numerator, and then eliminating the negative part of it. So the law says whenever you have a over b having a power of negative m over n, then it is suffice for us to say b over a raised to power m over n. Let's try to look at these two examples on the board. The first one says 32 over 50 raised to power minus 1.5. Firstly, we need to remove this negative part of the power. And don't forget that we say whenever we have a negative power, then we have to turn the numerator and the denominator upside down to remove the power. So this is going to give us 50 over 32 raised to power 1.5. And 1.5 is the same thing as 15 over 10, which is equal to how many 5 here? 3, 5 here, 2. So 1.5 is the same thing as 3 over 2. So we say 50 over 32 having a power of 3 over 2. Don't forget that we can rewrite this. Before rewriting, let's try to cut what we have here. 2 here 16, 2 here 25. So we have 25 over 16. And the power can be rewritten as 3 times 1 over 2. So don't forget that whenever we have 1 over 2, it is the same thing as square root. So we have square root of 25 over 16 raised to power 3. And square root of 25 is 5. So that says 5, and that is 4 having a power of 3. So 5 raised to power 3 is 125 over 4 raised to power 3 is 64. Of 32, x raised to power 4, y raised to power 2 over 162, p raised to power 6, z raised to power 8. So the first thing we are going to do in this type of question is to first reduce the whole numbers. We can cut the two of them by 2. So that is going to give us the square root of how many 2 can we get in 32? 16. And 2 in 162 is 81. So we have our x power of 4, y raised to power 2, p raised to power 6, z raised to power 8. Now, the next thing I need to tell you here is that whenever you have an alphabet having a power, which is also under a square root, what they are telling you there is to divide the power by 2. Don't forget that our square root of a is the same thing as a raised to power 1 over 2. And if this is having a power of 1 over 2, then x raised to power 4 in the square root is the same thing as x raised to power 1 over 2 times 4. Meaning 2 will cancel 4, and then you will have 2. So that is what we have to do in that case. So for each one of these, we are going to be dividing them by 2. And the square root of 16 is 4. Square root of x raised to power 4 will be x raised to power 2. And square root of y raised to power 2 will be y, divided by square root of 81 is 9. Square root of p raised to power 6 will give us p raised to power 3. And square root of z raised to power 8 will give us z raised to power 4. Try to solve these two questions on the board. Leave your answers in the comment section. And don't forget to subscribe to this channel if you have not done so. Until I meet you again, do have a blessed day.